everybody, my name is Tatiana and welcome to my video series on OTF Studio thin film software, a modern, smart and powerful software for designing, characterization, reverse engineering and monitoring of multi-layer optical coatings. In large area coatings as well as in the simultaneous production of multiple coating samples, it may be necessary to process multiple measurements at the same time. These measurements are typically related to different positions on the large area or to samples placed at various positions within the deposition plant. Application areas: architectural glass coatings for automotive, mass production, and large area coatings. To illustrate this option of OTF Studio, I will characterize a tantalum layer with plane thickness of 150 nanometer. I will assume that the layer is deposited on a large substrate. The layer is not uniform, and this is schematic representation of its front projection. The thickness is different at different positions, and there are totally 11 positions, and measurements were performed at each position. So there are positions from 1 to 11, and there are corresponding measurement data, transmittance, saved in TXT files. And this is schematic of top projection of the same layer, positions from 1 to 11. Position number 6 is the central position. I open OTF Studio project configured for this reverse engineering problem. It's easy to switch between different modes using quick access toolbar. Then I load tantalum layer material, non-absorbing, fuse silica substrate of 1 millimeter thickness. And then I load one layer tantalum design, 150 nanometer plane thickness. And then I need to import the measurements. So open import ribbon, spectrometers, XY data, and my folder opened. And here we can see TXT data files. And it's important to have position number in the name of the file. So I can select any file, open, and all these files, measurement files from this folder, will be in the panel, import panel. It's important to check multi-scan mode, import, and then the data, all 11 positions are imported to the measurement file, measurement spreadsheet. We can switch between different measurements, and in edit text, it's important to specify position because there are other types of data. Commit, and then there is a measurement which contains multiple measurements corresponding to different positions. In the characterization process, I assume that refractive index of tantalum is known accurately, and there are deviations at different positions from the plane thickness D. And these deviations, of course, are different for these positions, and the goal of this characterization is to find these deviations. So discrepancy function will estimate the closeness between model and measurement data and will be minimized during the characterization process. In OTF Studio, I open first fitting panel in view ribbon, and it shows model transmittance by solid line and experimental transmittance by position. So we can switch between different positions and see fitting for different positions. Compute model builder And model builder controls all reverse engineering algorithms and settings. Then, together with model builder, a thickness panel is opened. Then, in the model builder, I specify thickness model, so systematic, and there is only one layer, so we will look for an offset in this layer at different positions. Then run batch processing using batch tab, and very fast we obtain results history panel, which shows positions and partial discrepancies for each position. We can switch in history, we can switch between different positions and see partial fittings for each position. I removed thickness errors panel, and now I would like to plot, for example, discrepancies, partial discrepancies. View, batch, tab, and here new plot, discrepancy, for example, commit, and this plot shows discrepancy by position. There are other plots, of course. We can plot also, for example, thicknesses, commit. This is thickness profile, so thicknesses by positions, and position numbers are shown on the x-axis. Of course, it's possible to plot more characteristics like systematic thicknesses, refractive index, extinction coefficient. And this is very powerful option. And in the next videos, I will demonstrate this option for multi-layer coatings for more complex reverse engineering problems. Thank you for watching. If you have questions, please contact me and see you in the next video. Bye!